Today we'd like to talk about optical interconnects in high bandwidth wired communications. There are a huge number of system designers leveraging FPGAs to talk to a wide variety of pluggable optics. Those can be anything from the old Gigabit Ethernet modules to the latest 400 gig Ethernet arrangements. So how do you know if the optics you want to use will work in your FPGA-based design? That's what we're here to talk about today. In front of me, I have a collection of evaluation boards based on the Kintex and Vertex UltraScale FPGAs, Xilinx's latest generation of devices that feature a number of different optical interfaces. Starting on the right here, we have a KCU105 Kintex board with an CFP Plus module, a VCU108 Vertex board with both a QSFP28 module and a CFP2 module, and finally, I have another Vertex evaluation board, the VCU110 with a CFP4 here on the left. The optics here in front of me cover the most popular choices today and frankly generate the most questions with regards to which optics these FPGAs support. We could break this down a number of different ways, but I'm going to walk through these in order from highest to lowest margin generated by these links. Surprisingly enough, the modules here that support 25 gig links have a leg up because they all have retimers in the module. For 100 gig optical interfaces that utilize 4 lanes of 25 to 28 gigabit per second, every module is currently retimed. Let's take a look at the VCU108 and 110 to examine these 100 gig ports. The CFP2, QSFP28, and CFP4 plugged into these boards are all running 4x25.78 gig, 100 gig Ethernet rates. And despite the large difference in size and the fact that they are running different optical standards, all three support the same electrical interface, CEI 28 gig VSR. As you would expect, you can see here via IBERT that we're getting similar performance out of each interface. What that means is that the module itself guarantees fidelity in the optical domain. To reduce the power consumption per bit, our FPGAs are then free to disable some of the more advanced backplane-specific equalization, as they only have to guarantee the short electrical connection between the device and the module, about 10 dB or so. Easy. As such, we can support all retimed 100 gig modules, all QSFP28 modules, all CFP4 modules, and all CFP2 modules, all the way to our max rates. To go one step further, because there are some standards that expect errors in the optical domain that could be misread and retransmit into the electrical domain, we have 802.3 RSFEC IP that can be implemented in the fabric to correct for those errors that may occur elsewhere in the channel. 10 gig links can either be retimed like their faster 25 gig brothers or unretimed, as most CFP Plus modules are. In either 10 by 10 gig or single 10 gig formats, Xilinx is able to receive these signals error-free, even in the cases where retimers are not used. That includes protocols like OTU2, OTU2E, 10 gig base LR, ER, SR, OC192, and a wide variety of others. As you can see, with the Kintex and Vertex UltraScale FPGAs, Xilinx has enabled you to interface to the most popular 10 gig and 100 gig optical interconnects, including CFP Plus, QSFP28, CFP2, and CFP4, with the transceiver performance and IP to help ensure success. For a complete picture on the standards supported by the UltraScale transceivers, please visit xilinx.com/transceivers. Thank you for watching.